Here's one more solution video. Paper 32, March 2022. Question number 1. Solve the inequality of two absolute functions on both sides. So let me square both sides to make it independent of absolute sign. So it will become 2x plus 3 square on this side greater than 3 absolute x plus 2 square on this side. Whole of it is squared, okay? So it will be expanded as if it is a plus b whole square, and a plus b whole square is a square plus b square plus 2ab, correct? So it will be a square 4x square, square of 2x, then square of 3 9, then 2 times a and b greater than, this will be 9, and then we will square the x plus 2 also, a square plus b square plus 2 times a b. So 4x square plus 9, and this will be 4 times 3 12x is greater than 9 x square plus 9 times 4 36 plus 4x times 9 36x. Let's collect everything to the left side. 4x square minus 9x square plus 9 minus 36 plus 12x minus 36x. All of them change the sign when they move to left side. 4x square minus 9 square is minus 5x square. 9 minus 36 is minus 27. 12x minus 38, 6x is minus 24x. Greater than 0. This leading term has a negative, so let's make all of them positive. So 5x square means change the sign, not positive, change the sign of all of them. Plus 24x plus 27, but we can't do it without compensating it. So whenever we change the sign of the whole inequality, the sign changes. So it becomes less than 0. Now, this becomes a quadratic inequality for us. Let's find the roots of this quadratic expression. So it will be 135. 15 times 9 is 135. So I'm factoring it. You can straight away use your calculator. These days, calculators are so capable that they can give you the roots straight away. I am using the old tested method of using the factorization method. Okay, 27 less than 0. So what do we get here? 5x is common here, so x plus 3. 9 is common here, x plus 3. So 5x plus 9 and x plus 3 less than 0. So now we have two roots here. 5x plus 9 equal to 0. I'm not writing it less than, okay? Because I'm interested in roots, not the solutions. X plus 3 is equal to 0. Here x will be negative 9 over 5. X equal to minus 3. Next thing we should do to find the final solution is that divide a number line into 3 parts. Write the smaller of the two. The smaller is minus 3 on the left side, the greater of the two on the right side. Okay, now our original equation was not equation, inequality was this absolute inequality. So we'll take a number less than minus 3. So 2 times minus 4 plus 3 absolute is greater than 3 times negative 4 plus 2. So negative 8 plus 3, negative 5 is greater than 3 times negative 2. Okay. So minus 5 absolute, when I remove them it becomes 5 greater than. This is positive 2 when absolute is removed, so 6. Is 5 greater than 6? No. That means this is not our answer. Let's take a number between minus 3 and minus 9 over 5, which is minus 1.8. So minus 2. Minus 2 will be between them. So same process for minus 2 now. 2 minus 2 plus 3 absolute greater than 3 minus 2 plus 2. So this becomes how much? Minus 4 plus 3 minus 1 absolute greater than 3 times 0, 0. 1 is greater than 0, that's correct. This is our answer. And as usual, I will not do the third one, I leave it to you. I'm sure it will not be the answer. Please verify yourself, and always in exam never leave it like me. I'm a little lazy here to focus on the solution now. The solution is here. Minus 3 is less than x is less than minus 9/5. This is the solution of the inequality. Question number 2. On a sketch of an Argand diagram, shade the region whose points represent the complex number z satisfying these inequalities. The first one is z plus 2 minus 3i is less than or equal to 2, and second is argument of z is less than or equal to 3/4 of pi. Let's focus on this. Whenever we have such an inequality, always separate the reference point from the z by putting a negative sign in between. And how will that not change it? If I put minus 2 inside and plus 3i. So what I did, I took minus out of them, and this minus is must, because this z unknown complex number is with reference to this point. So let's see, where is this point? Minus 2 on real axis, so let's say minus 2 will be here, and on imaginary positive 3. So 1, 2 and 3. From here I need a modulus less than or equal to 2. I think I need to shift this because I need some space. So that being the center, we will draw a circle so that we get a modulus less than 2 units. So let me do this way. It has to be 2 units, right? So my scale is not good, that means. It looks an ellipse, but actually it's a circle, okay? Because if this is our point, our radius will be less than 2, because this is 2 units this way and 2 units up to this. So we will shade inside, and that becomes z minus minus 2 plus 3i is less than or equal to 2. This is the shaded region. But I'm unshading it because there is one more requirement. That requirement is this. Argument z, I will also write minus and 0. There is nothing after z, so I will write z minus 0. That means 0 becomes the reference point, the half line of the argument. So that means this is your reference point, and from here we'll draw the half line, which is the x, not real axis, and from this point I will draw an argument of 3/4 pi, which is equivalent to 45 degrees. So 45 degrees will be here. Let me draw a line. This is argument 3/4. From here to here, this is 3/4 pi. Alright, and now it is less than 3/4 pi. So less than is this way, less than 3/4 pi. Okay, that means I have to shade on the right of this particular line, but I will shade only inside the circle. Why? Because previously the whole circle was shaded. Now I'm shading this area which is common with the second condition. argument of z is less than equal to 3/4 pi. So this is the final drawing. Question 3. The variables x and y satisfy this equation when n and c are constants. The graph of ln y against ln x is shown here. It has these 2 points shown on the graph, and they are forming a straight line. Find the value of n and find the value of c correct to 2 decimal places. Since we see that they are forming a straight line, we can write the equation of a straight line, which is y minus y1 equal to m x minus x1. y1, x1, they are the coordinates of any point on the line, so we can choose any one of these two. So we can substitute the point. Let me choose this point. So x is 1.06 minus, and there will be a bracket here. M is needed, but y1 is 0.91. Now x and y, I have left blank spaces. Why? Because x is not actually x. X is ln x in this case, because the graph is between ln x and ln y. So in place of x, we will write ln x. In place of y, we will write ln y. Now m is remaining, which is the gradient of the line. Gradient is y2 minus y1 over x2 minus x1. So basically, in this case, it will be ln y2 minus ln 1. But since these numbers represent ln y and ln x, we'll use them. So 1.21 I'm taking as y2 minus 0.91 over 0.31 minus 1.06. So 1.21 minus 0.91 will be 0.3. Divide by, okay, 0.31 is smaller than 1.06. So it will be 0.75, negative 0.75. So can we somehow simplify? Let's give it a one more decimal place, and now we can ignore decimals. 30 over 75 becomes, negative was already there, so 15 times 2 is 30, 15 times 5 is 75. Minus 2 over 5 is the gradient of this straight line. So we will write here now, minus 2 over 5. And now our target is to reach to this format. Let's collect the natural logs together first. So natural log y plus 2/5 of natural log x, right? This is ln y, and this minus 2/5 times ln x I brought to the left side together. All right, this minus 0.91 will be positive 0.91 here, and this will be this minus, and this minus will become positive 2/5 times 1.06. all right, we can't merge these two natural logs. First, this has to become an exponent, so it will become ln y plus ln x to the power 2/5, positive 2/5, equal to 0.91 plus this. Let's turn them into one number. By the time I use my calculator to find the value of these two together, please subscribe to my channel and like this video, share with your friends so that they also get benefited, and I'm motivated to make more such videos for you. Okay, when I use my calculator, I got 1.334. Now we can merge these two natural logs because there is nothing in front of lns now, so it will become ln. Since it is adding, so the contents will multiply. Y multiplied by x 2/5 equal to 1.334. But our target does not has any ln, so we'll liberate them by removing natural log. When we remove natural log from one side, the other side becomes the power of e. Now it's matching somewhat here. So let me, because they want y square, so let's square both sides. So it becomes y square x to the power 4/5, right? 2/5 times 2 is 4/5, equal to e to the power 2.668. Now we have somewhat like this, and we have to get a constant here. It is a constant. Let's evaluate this and write our final answer. So it comes out with 14.43 significant figures here, and y square x 4/5 on the left side, and now it is matching exactly with what they want. So n, the value of n is 4/5, value of c is 14.4. Question 4, in which we have been given two equations x and y in terms of a common variable theta. We have to find dy over dx and show that it is equal to this. So we have the equation for x first, so let's differentiate it with respect to theta so that we get dx over d theta. Differentiation of 1 is 0, no need to write it. Then we have a minus, and differentiation of cos theta is minus sine theta. So this becomes positive sine theta. Let's talk about dy over d theta when we differentiate y with respect to theta. Differentiation of cos theta is minus theta minus sine theta again, and minus 1/4 is minus 1/4. Differentiation of cos 2 theta will be minus sine 2 theta multiplied by the differentiation of the angle, which is 2. We can cancel this 2 with 4. So we get minus sine theta plus 2 negatives will make it plus sine 2 theta over 2. But our job was not to find dx over d theta or dy over d theta, it was dy over dx we had to find. So dy over dx will be dy over d theta multiplied by d theta over dx. So that d theta and d theta cancel out, we are left with dy over dx. dy over d theta is this, minus sine theta plus sine 2 theta over 2. Now we need to multiply this with d theta over dx, but we have here dx over d theta. That means we'll have to reciprocate this so that we get the reciprocal of it, 1 over sine theta. Now 1 over sine theta multiplies with minus sine theta, we get minus 1. When sine 2 theta multiplies with this, we get plus sine 2 theta over 2, and then sine theta multiplies the denominator. But it is nowhere near to what we want here. Here I would like to mention one identity, which is cos 2a equal to 1 minus 2 sine square a, because they want sine square from this, that's why I wrote this. So somehow this format should be in this format. Okay, so let's write equal to minus 1, and there is an identity for sine 2a also, 2 sine a cos a. This will give us the desired answer we want, sine a cos a over 2 sine theta rather. So 2 cancels with 2, sine theta with sine theta, we are left with minus 1 cos theta. Now I was talking about this identity. Can I rewrite this as minus 1 plus cos theta it is. Now let's rearrange this one. Can I write it that this one, when it goes to the left side, becomes minus 1 plus cos 2a equal to minus 2 sine square a. And now if I look at this equation, it will be again minus 1 plus cos, and I want to match with this 2 theta over 2. right? How did I get this hint? Because look what they want us to show. They want half theta, and that's why I thought that converting it to half theta would help, right? So now look, it is exactly matching with this one. In place of a, we have theta by 2, right? So we'll have the right answer, right hand side as the answer, minus 2 sine square a is theta by 2 for us. And this is exactly what they want us to show. Moving on, the angle alpha and beta lie between 0 and 180, both of them. Okay. They're such that this is equal to 2 and tan alpha is 3 tan beta. Okay. Find the values of alpha and beta. So we have two equations, two variables. Let's try to make something out of that. So tan alpha plus beta, if we use the identity, tan alpha plus beta will be tan alpha plus tan beta over 1 minus tan alpha tan beta. They said it is equal to 2. And here they're saying tan alpha is equal to 3 tan beta. So wherever we have tan alpha, let's replace by 3 tan beta. Yeah, done. Now 3 tan beta plus tan beta will be 4 tan beta over 1 minus 3 tan square beta equal to 2. So by cross multiplying, this will multiply with 2, so we'll be left with 4 tan beta equal to 2 minus 6 tan square beta. Let's bring these two to the left side so that we get a quadratic equation 6 tan square beta plus 4 tan beta minus 2, right? Yeah, this 2 will become negative, equal to 0. This becomes a quadratic equation which can be simplified by dividing by 2 all of them. Let's simplify because all of them are even numbers. What do we get? 3 tan square beta plus 2 tan beta minus 1 equal to 0. And now we will find the values of tan beta with the help of assumption. Tan beta, let's assume that is equal to m. So our equation becomes 3m square plus 2m minus 1 equal to 0. And we'll factor this to find the values of m. 3m square plus 3m minus m minus 1 equal to 0. If you're not comfortable with this factorization, please use your calculators to give you answers straight away. Okay? I use factorization. So what do we get? M plus 1, 3m minus 1 equal to 0. So this one gives us m equal to minus 1 when we equate it to 0. This gives us 3m equal to 1, so m equal to 1 over 3. So m was not there initially. We assumed tan beta equal to this, so we get two answers here. Tan beta equal to minus 1, tan beta equal to 1 over 3. And initially they said they are between 0 and 180 only. So let me confirm if it is 0 to 180 or something else. Yes, 0 to 180. So tan beta is minus, tan is negative here. So if I put now beta equal to tan inverse 1, not negative anymore because the quadrant is decided, we get this angle as 45 degrees because tan inverse 1 is 45 degrees in second quadrant, but our answer will be this one. From here till here, which is beta equal to 180 minus 45, 135 degrees, because this line is 180 and this is ending 45 degrees before this line. So this is the answer here. Here beta is tan inverse 1/3 tan is positive. Tan is positive only in this quadrant, first quadrant. Let me draw a different drawing for this. So the angle we'll get will be here, tan inverse 1 over 3. Let's try to find this one. I get this as 18.434, and which is actually the answer. Beta will be, let's write 18.4, 3 significant figures. So this is beta. What about alpha? Let's take the help of the previous equations for alpha. Tan alpha is equal to 3 tan beta. So let's do it here. So tan beta is minus 1. Tan alpha is 3 tan beta. Tan beta is minus 1. So tan alpha equal to 3 times minus 1 minus 3. Again, tan is negative in this quadrant, right? So find out what is tan inverse 3, not negative, okay? Because the negative has already given us the quadrant. So tan inverse 3 is 71.6 approximately. So our answer will be from 0 till this line. So here alpha becomes 180 minus 71.6, which is 108.4 degrees. Similarly here, tan alpha equal to 3 times tan beta. Tan beta is 1/3. Cancel out. Alpha equal to tan inverse 1, and it's in first quadrant 45 degrees. So these are the combination of answers. We have 18.4 and 45 degrees, one combination, 135 degrees and 108.4 second combination. Next one is this. And the best thing I'm liking about this paper is that there's no ABC part or 1-2 part, straight away one part questions. Number 6 says find the complex numbers W which satisfies this equation. And please understand that this star means conjugate of W. Okay, so W square plus 2I its conjugate is equal to 1 and are such that the real part of W is less than 0. It's negative. Okay. Give your answers in the form of x plus iy, where x and y are real numbers. So let's use the format they have asked in this equation. They have asked x plus iy. So in place of w square, I will write x plus iy square plus 2I. W star means its conjugate, so x minus iy equal to 1. Let's open this bracket by the same identity we have used earlier. A plus b square equal to a square plus b square plus 2ab. So x square plus I y square plus 2 times x I y plus 2ix minus 2I square y. And let's take this one also to the left side. Nothing is left on the right side. Let's simplify this. X square, I square will be minus 1, so it will be minus y square plus 2xiy plus 2ix minus, this I square is minus 1, so this minus will become positive because of that, and we'll be left with 2y minus 1 equal to 0. Now since nothing is getting simplified further, so this 0 can be written as 0 plus I0, right? I can write that because it is not going to make any difference, which means that the real part will be equal to real part, imaginary part will be equal to imaginary part. Let's start with the imaginary part, which looks easier. X, I, y. This is one imaginary part, this is the second. 2ix is equal to 0i. So I we can cancel from all of them. So let's take 2x common. Y plus 1 equal to 0. So it gives us two answers because of 2 multiplying equal to 0. X is equal to 0. And this gives us y equal to minus 1. So now we have to find the counterparts of both because x and y are different. So let's write the second equation with the real parts. X square minus y square plus 2y. Okay, x minus square 2y minus 1 is also real, right? Okay, equal to 0. Now we have x equal to 0. Let's put x equal to 0 first. So 0 minus y square plus 2y minus 1 equal to 0. Let's change the signs of all of them so that this y square becomes positive. Y square minus 2y plus 1 equal to 0. Let me factorize, though I know what is it, but let's factorize this to find its two parts. So minus y plus 1 equal to 0. So we get y minus 1 square equal to 0, which gives us y equal to 1. So the first combination, when x is 0, we get y equal to 1. That's what we got, right? Our format was x plus iy, if you remember. So x is 0. W is equal to 0 plus I, and y is 1 we got. That's it. W equal to I. This is our first. Second, when y is minus 1. So same equation we'll write, but let me use the upper part this time. Here, x square minus 1 square plus 2 times minus 1 equal to 0. X square, and this will be positive 1, but this negative will make it negative again. Minus 2 minus 1. Alright, equal to 0. Which comes x square equal to x square minus 4 equal to 0. And that gives us x square equal to 4, and square root both sides. Sorry for this complicated part. So plus minus 2. Alright. So when y is minus 1, x is plus or minus 2. So you get value of w here, x plus iy. Let's take plus 2 first. 2 minus I, right? Because this was the format. Here I put x equal to positive 2, y equal to minus 1. Now second can be w equal to 2 minus 2 and minus I. These would be the three answers. However, if you look at the question, they said real part of w is less than equal to 0, and we can't accept this one. So these two are the answers. Welcome to part 2 of the solution video of paper 9079, paper 32, Pure Math 3 of Cambridge International A-Level Math. Question number 7. By sketching a suitable pair of graphs, show that the equation 4 minus x square and secant half x have exactly one solution in the interval 0 to pi. Alright. Now, since it is just of 2 marks, it will not be a wise idea to make a table and then join the points to draw graphs. It will consume some time. You should have basic knowledge of this particular equation. We divide this equation into two parts. The left part is y equal to 4 minus x squared. That becomes one function. Second, on the right side, it becomes y equal to secant half x. Whenever they ask us to solve through a graph, we make left and right different functions and see where they intersect. All right. 4 minus x square means we have some transformation from the parent function y equal to x square. What? This negative will reflect the graph in opposite way. So y equal to x square graph is from origin something like this, right? But the one with minus x square will be reflected because of negative on here, this particular part only. Now, there is an additional 4 here. Can I write this as y equal to minus x square plus 4? I change their places. Minus x square is the graph this way, correct? Plus 4 will have a vertical translation of 4 units. That means the whole graph will go up by 4 units. This is 4. The graph will be something like this. So let me draw that graph. So 1, 2, 3 and 4. And since the graph is always uniform, the x-intercepts will be make y equal to 0 in this. So 0 equal to 4 minus x square. So x square you can bring to the left side, x square equal to 4 and square root both sides, x equal to plus minus 2. So plus 2 and minus 2 will be the two intercept, this and this. That means the graph of 4 minus x square is this way and this way, very uniform kind of graph. Okay. Now let's talk about this one. Again, we'll use logic. If you use points, it will be difficult for you to see how it will look like. Okay, so for that, I should show you what a cos graph looks like, because secant is reciprocal of cos. A cos graph looks like this and it finishes as 2 pi, right? So the secant graph will be reciprocal of this. So 2 pi we can take reference here. I'm not looking at half right now, okay, just secant x I'm drawing. So the maximum of a cos graph is 1, the minimum is minus 1. So reciprocal of 1 is 1, so this will be the point. Reciprocal of 0 is undefined, so we will draw an asymptote at that level. Okay, this angle is pi by 2. Then we have pi here where it has minus 1. Okay, so the reciprocal of minus 1 is minus 1. So at pi, it will be minus 1 here. And at 3 pi by 2, it is 0 again. So 3 pi by 2 is between pi and 2 pi. Now, what is the shape in between? You can see it is going down, down, and down. As the number decreases between 1 and 0, its reciprocal increases. For example, this point is 0.5. Its reciprocal 1 over 0.5 will be 2. If a very small point here is say 0.01, 1 over 0.01 will be 100. That means the graph of secant will go up, not down. From 1 it will go up, but it will not touch this asymptote. And pi by 2 is 1.57. Because of this half, the period doubles. Whenever there is a coefficient in front of the angle x, whatever is that period divided by that number is the new period, and divided by half makes it double. That means this will not be pi by 2 anymore, it will be pi, which is 3.14, not 1.57 anymore. So 3.14 is much beyond 2. This was 1, this is 2, this is 3, and this is 4. This asymptote will be here somewhere, correct? They are saying, show by sketching that it has exactly one root between 0 and pi. So pi is 3.14, this asymptote, right? And our shape is this way, from going from 1. This is 1. And meeting the asymptote. Please keep in mind that this scale is always in radians for trigonometric ratios in these kind of situations. Never use degrees. Degrees will give you a very wrong answer. And now here we can see that two graphs, white and the orange one, are intersecting at one place, and that's why we can say that they have one solution. I used logic previous knowledge to get this explanation took some time, but if you do it in exam with proper way, it will not take hardly, it will take 4 to 5 minutes to do it. Alright, let's go to the second part. Verify by calculation that this root lies between 1 and 2. We can see here it is between 1 and 2 in our graph. This is 1, this is 2, and our solution is somewhere in between here, maybe 1.5, 1.6, but we have to show that it is actually lying between 1 and 2. So we'll use the same formula, 4 minus x square equal to secant half x. 4 minus x square equal to secant half x. To show that it is between 1 and 2, always collect all the terms to one side. Let me collect them to the left side. 4 minus x square minus secant half x is equal to 0. So whatever is the value of 0, that will make it equal to 0, this equation, right? But if we put 1, what do we get? Let's see. If x is 1, of course it will not be 0, right? Because 0 is the solution. 1 and 2 are not the solution, but they will give some different numbers. So let's put them here. 4 minus 1 square minus secant half times 1. This is the angle. And we are not interested in 0 because it does not give you 0. 4 minus 1 square is 1, 3. 3 minus secant half, let's say 0.5. Put this in a calculator. Let me try myself. What I get is 1.86, positive 1.86. Alright, let's try what do we get when we substitute 2. So when x is equal to 2, 4 minus 2 square minus secant half times 2. This 2 and this 2 cancel. And let's see, 4 minus 4, right? 0. They are also gone. We're left with minus secant 1. Okay, you might be wondering, how do I get secant? Because there is no secant in our calculator. So what I'm doing actually, I am converting it to minus, and secant is 1 over cos. So it will be 1 over cos 1. In this case, it was 1 over cos 0.5 when I put in my calculator. This gave me minus 1.85. So with 1, we got a value of 1.86. With 2, we got negative 1.85. That means it crossed 0 in between, because it's positive here, it's negative here, that means 0 is in between. And we want equal to 0. So equal to 0 means root, the solution of this is between 1 and 2 if we put some values. So we can write the change in sign indicates that the root, root lies between 1 and 2. Okay, C part. Use iterative formula this to determine the root. So they have already converted it to an iterative formula. We just have to plug in values, and which values they have not told us where to start. But since we know the root is between 1 and 2, so let's start with 1.5, which is exactly in middle. So we'll take the first root, x1 equal to 1.5, and plug in this one. Where? Here. So x1 will be 1.5, right? So secant half times 1.5. 4 minus square root. This is x1. So x2 will be this. In place of x1, I wrote 1.5, which became xn. x1 plus 1 is x2. That will be this one. And if we use calculator, we get 1.6227. They said 4 decimal places, right? And now this x2 will be used in place of x1 here. So we get x3. 4 minus secant half 1.6227. That gives me 1.5961. Let's go to x4. 4 minus secant half times 1.5961. I get 1.6024 to 4 decimal places, and now we'll stop. Why? Because you can see if I round off this one, it will give me 1.60. If I round up this to 2 decimal places, 1.60, they are exactly same. When our rounding off is same at the number of decimal places they want 2 decimal places, we stop. That means our value is 1.60, which was visible from our graph as well. Going on to the next question. Find the quotient and remainder when this big polynomial is divided by 4x squared plus 1. So basically this cannot have factors because it's a plus here. So we'll have to do long division in this case. So 4x squared plus 1, it divides 8x cubed plus 4x squared. 2x plus 7. Quotient will come here. First 4x squared. What should I multiply this with so that I get 8x cubed? 2x. So 8x cubed. And then 1 also multiplies with 2x. So 2x can be written on this 2x. Minus and minus both cancel out. So now we are left with 4x squared plus 7. So we can write 1 here because 4x squared is exactly as 4x squared and plus 1 under 7. First let's write 7 and then we can write the multiplied part. So again we subtract both, this cancels out, but here we are left with 6. So we have 6 as remainder and this is quotient and this is what they wanted. Okay, hence second part B, find the exact value of this integration. So it is exactly same. Yeah, big polynomial divided by 4x squared plus 1, and that polynomial is exactly what was in the first part. That means we can write this one as a complete number which is quotient 2x plus 1. Let me write it separate. Dx from 0 till half plus we'll get remainder over 4x squared plus 1 separate. So it becomes a complete function and then a rational function, part of the two, from 0 to half here as well. Okay, so now we'll have to integrate them. This part is easy to integrate. It will be 2x squared plus x. I'm writing c with the next one, so I will stop it here. 0 to 1/2. So let me keep it safe here and let's focus on this one. Can I write this one as 0 to half integration 6 outside 1 over 4x squared plus 1 dx, right? When we have a perfect square, even if it was not a perfect square, we would make it somehow, but this is a perfect square plus 1, so we would assume its square root. What is square root of 4x squared? As tan theta. Why? Because it will become tan square theta plus 1. That's what we want. So basically 2x is equal to tan theta. So 4x squared, if I square both sides here, look, it becomes 4x squared equal to tan square theta. And that's what I will use it here. First, let me change dx also. To get dx, let's rearrange this 2x. So can I write this as x equal to half tan theta? 2 went and became a denominator here. Now dx over d theta, we can differentiate it with respect to theta. Half, and differentiation of tan theta is secant square theta. Alright, so that means dx equal to half secant square theta d theta. And this is what we wanted here. Let's substitute everything. I'm keeping this one safe, keep in mind, okay? So 6, 0 to half, 1 is 1, but 4x square is tan square theta. That was the purpose, plus 1. Dx now has changed to half secant square theta d theta. Now, this 2 and this 6 can cancel. Tan square theta plus 1 is actually secant square theta. That's an identity. That means this will cancel with this. We are just left with 3 and sorry, I don't have to write when we have theta, we can't write 0.5 here. We'll go back to x later. So I'm not writing limits also. So nothing is left here, only d theta is left. Okay. What is the integration of this with respect to theta? It will be 3 theta plus c. And theta was our creation, it was not existing earlier. And what was theta? It will be, from here we can get what is theta. From here we get theta is tan inverse 2x. Isn't it? From this equation. That's what we will write here. It becomes 3 tan inverse 2x. That's our differentiation, sorry, rather integration of this. And we can write here plus c and 0 to half. Now combine what we had written earlier and this together. 2x square plus x. Actually, it is not 2x square plus x. 2x is integration is 2x square over 2. So 2 and 2 cancel. It will be x square plus x only. Okay, x square plus x. So earlier we had x square plus x plus now 3 tan inverse 2x plus c from 0 to half. And now we'll plug in half and 0, we'll get our answers. So first is half square. So half square plus half plus 3 tan inverse 2 times half plus c when we substitute half. Now we'll have to plug in 0. 0 square plus 0 plus 3 tan inverse 2 times 0, 0 plus c. C and c cancel out. That is the first thing we do. This is 0, and tan inverse 0 is also 0. That means this whole thing is gone. There is no use. Just focus on the first part. It will be 1/4 plus half plus 3 tan inverse 1 is pi by 4. You can use your calculator, put tan inverse 1, it will give you pi by 4. So what do we like? This is also 3 by 4 plus 3 by 4 pi. We can see 3 by 4 is common. We can write 3 over 4, 1 plus pi. That is the value of that definite integral. Okay, another question with no other part, just one. The variables x and y satisfy this differential equation. It is given that y is equal to 1 and when x equal to 1. Just like in many questions they do to get certain value. Solve the differential equation and find the exact value of y when x is 3. Alright, giving you answer in a simplified form. Okay, so the first thing first. The rule is that our dy and dx should be separated and they should be numerators. This dy is numerator, that's fine. Dx is not, so bring it with y. So it becomes x plus 1, 3x plus 1 dy will remain here, and here we'll get dy and dx. No d, alright. Now second rule. The y should be with dy and x's should be with x. So let's bring y to with y. It becomes 1 over y, right? Because it's a numerator here. When it cross multiplies, it's multiplying here. So it will become a denominator. And these two will become the denominator of the other side. X plus 1, 3x plus 1 dx. So x's are with x, y is with y. And now we can integrate both sides to get the equation of the curve. Okay. When we integrate y with respect to y here, so it will get ln y here equal to, now we have two parts here which we can separate with the help of partial fractions. So let's assume 1 over x plus 1, 3x plus 1. Let me confirm it is plus 1, right? Yes. Equal to a over x plus 1 plus b over 3x plus 1. So this denominator multiplies with b, it is just x plus 1. And this denominator multiplies with a. Why? Because we multiply them by each other to get the same denominator as left side, so that we can ignore the denominator of left side as well as the right side. There is no denominator anymore. Now, assume x equal to minus 1, so that this becomes 0, right? So 1 equal to a 3 times minus 1. We have assumed minus 1, right? 3 times minus 1 is minus 3. Minus 3 plus 1 is minus 2. And this will become 0. That's why we assumed minus 1. Minus 1 plus 1 is 0. That means this part can be ignored. So we got a equal to minus 1 over 2. Similarly, assume that x is equal to, how can this become 0? Minus 1/3. If x is minus 1/3, 3 times 1/3 will be minus 1, and minus 1 plus 1 will be 0. That's the purpose. So let's assume this. Our equation will become 1 equal to, this part is 0. The b part will be minus 1/3 plus 1. Okay. So we get what? 1 equal to minus 1/3 plus 1 is 2/3 b. So b becomes 3 over 2 by cross multiplication. 3 multiplies here, 2 comes down. b is 3 over 2. So now our right side of this one becomes minus half x plus 1. Yeah, that was the one. Yes. And then we have 3 over 2 positive. Yes. Plus 3 over 2, 3x plus 1. Okay, and then we integrate both of them with respect to dx. Alright, so ln y here equal to, now this becomes minus half is constant, don't touch it. 1 over x plus 1 will be ln x plus 1, the integration. Similarly here, plus 3 over 2, we can write here absolute sign also, that's fine. 3 over 2 ln 3x plus 1, but we'll have to divide by the differentiation of the content of the linear denominator we have, so we have to divide by the differentiation of 3x plus 1, which is 3. So divide here, so 3 and 3 cancel, and then we have plus c as well. Okay, so we get here ln y equal to minus half ln x plus 1 plus 1 over 2 ln 3x plus 1 plus c. Okay, to find c, they have given a situation. When x is 1, y is 1. Let's put x and y equal to 1 so that we get the value of c here. So ln 1 minus half len 1 plus 1, which is 2, plus half, did I write equal in between? No, I did not. Okay, plus half len 3 times 1 is 3, it becomes 4, plus c. Now there are 3 lens, let's club them together. Len 1 is 0, so don't even look at this one. This one becomes positive, and half len 2, it will be minus half len 4 equal to c. Now half can become exponent of these numbers, so len 2 to the power half minus len 4 to the power half. Now since both of them are len, we can club them and make 1 because they are subtracting. If they subtract, their contents divide. So over 4 to the power half. So whenever we have same exponent over two numbers which are dividing and they are different, we can divide them actually and keep the same exponent. Sorry, I shouldn't write half here. So it will be len 2 divided by 4 is half to the power half. Both, it applies to both and they cancel out 2 and 4. Equal to c, so we can write c equal to, let's take half again outside because I need to match them with what we have here. Half we have to, half will be good with this c so that we can merge them. So let's write them now. Len y equal to, now this has half minus half, this has positive half, and c also has a half. So let's take half common out of them. What is left inside? Here we are left with minus len x plus 1. Then we have plus len 3x plus 1. And then we have len half plus len half. So we can now, since all three of them are len, we can write them as 1 natural log equal to half. These two are positive, so let's multiply them. Len half, right? So half multiplied by 3x plus 1, and because it's subtracting, it will write, okay. And did I write len? I did not write len. That is bad. Okay, len will be here. So now this also has a len and this has a len. Let's give this half to them as an exponent, so that we can remove len later. So len y equal to len 3x plus 1 over 2x plus 1 to the power half. Now both of them have len. Now we can neutralize them, means we can just write the contents. Y equal to, this power half is square root 3x plus 1 over 2x plus 1, and done. They had given one more part to this. They said find the value of y when x is 3. It is worth 9 marks, and rightly so. So when y is equal to 3, x is equal to 3. So y equal to 3 times 3, let's write here, when x is equal to 3, this is the one, plus 1 over 2 times 3 plus 1, which is 9 plus 1, 10 over 3, 2 times 4 is 8. So they can cancel. Answer is square root 5 over 4, because they said write in the simplest form, simplified form. That is the simplified form, square root 5 over 4. Let's say point A is here, and whatever is the position vector become its coordinates. So 2, 1, 1, they are the coordinates, the position vector interpreted into the coordinates B. its coordinates will be 1, minus 2 and 2. Alright, they are the 2 points. And line L has a vector equation, this and line L, they are not passing through this. So let's say this is line L. And this is the equation of this line L. Okay, part A, find a vector equation for the line through A and B, line through A and B. Let's draw a line. So we have to find the vector equation of this line, whereas the vector equation of this line is given to us. So we need a point which will be the position vector of any of the 2 points. Let me take 2, 1, 1 as the point part. So A part, it will be R equal to, and the position vectors are 2I plus J plus K for A. Right? This is what I used. Plus, let me use a parameter. They use mu here, so let me use alpha. Okay, now I need a vector inside which is passing through A and B, and which is nothing but vector AB. So since B is the head, we will write the position vector of the head first, which is because AB is OB minus OA. Position vector of B, head, minus position vector of tail. Alright, OB is 1 minus 2, 2. I minus 2j plus 2k. OA is 2i plus j plus k. 2i plus j plus k. Let's open the bracket and simplify. 1 minus 2j plus 2k minus 2i minus j minus k. Okay, I minus 2i is minus I. Then 2 minus 2j minus j will be minus 3j. Okay, and then 2k minus k is k. So this is the direction vector of AB, which shows the direction, and that vector we will write here in the bracket. Minus I plus 3j plus k. This is the vector equation for AB. Let's see what are they saying about the second part. Find the acute angle between the directions of AB and L. That means we will have to increase this line to further extend both of them and extend this as well, and we have to find this angle, right? Okay, so they're saying the acute angle, so we have to find acute angle. If there is an obtuse angle, because you know when two lines cross, they make acute as well as obtuse angle. If we get an obtuse angle, we'll subtract from 180 and we'll get the acute angle. So that doesn't matter, we'll just find the normal method of finding angle between two vectors. Now these are just position vector. The first parts are position vector. This one is position vector. We will not take care into this because this represents only one point from origin. Suppose origin is here. So don't take point for finding angle. Take the direction vector, and the direction vector is this one. Okay. Let me write this vector first, which I think I made a mistake. There's a negative here. I got negative, and here I wrote positive. So this is negative again. So minus 1, minus 3, 1. That's the column notation I'm writing for easiness, cleanliness. Okay, the direction vector of the L was 1, minus 3, minus 2. 1, minus 3, minus 2. So we know that the dot product of two vectors is equal to the magnitude of the first multiplied by the magnitude of the second, and then cos theta, the angle between them. Let's find the dot product first, which will be this one. Minus 1 times 1 is minus 1. Minus 3 times minus 3 is plus 9. 1 times minus 2 is minus 2. So it is minus 1, 8, minus 2, 6. 6 is the dot product of A and B. Now we have to find magnitude of A, means the first line. AB is the first line, right? Its magnitude we have to find square root minus 1 square plus minus 3 square plus 1 square, which is 1 plus 9, 10 plus 1, 11, square root 11. Then we have to find the magnitude of line L, which is square root 1 minus 3 minus 2. 1 minus 3 minus 2 square, which is 1 plus 9 plus 4, 10 plus 4, 14, square root 14. So now we have everything ready with us. The raw material is ready. We have to find angle through this. A dot B, 6. Absolute A, square root 11. Square root 14 is absolute B, and then cos theta. So we'll take these two and cross multiply. 6 divided by square root 11 square root 14 is cos theta. That means theta will be cos inverse of 6 over square root 11 square root 14. Let me use my calculator to find this. By the time I do this, I would request you to subscribe to my channel. I think I'm the first person in the world to solve this exam for you guys. Please like this video, share with your friends, and motivate me to make more videos and share this knowledge throughout the world. Thank you. I got is 61.086, which we can write as 61.1 degrees. Alright, next part. Show that the lines A through A and B, means that line, the first one, AB, and L do not intersect. That is the easiest part if we take care of all the calculations. So what do? Let me copy both of them first, and then we'll start. So I got them here now. So let me write two parametric equations for both of them. So here, x equal to, from this one, it will be 2 plus, rather minus 1 alpha. So I will write just alpha because there is minus 1 here, right? Then we have 1 plus, but this is minus 3 here. It will be minus 3 alpha. This is 1. Then we have z equal to 1 plus 1 alpha. 1 plus alpha. Similarly, this is line L. We'll write for this also, x equal to 1 plus mu. Then we have 2 minus 3 mu. Then we have z equal to minus 3 plus, you guessed it right, minus 2 mu. So since if they intersect, they should have these x equal to this x, y equal to this y, z equal to this y. We'll prove that they don't have same x and y. You might be wondering, how did we find angle then? Okay, we found the angle between the vectors, not the exact lines. So it's possible that they are on different planes, and that's why they're crossing on those planes, right? And their parallel lines are making some angles. So that's why, don't confuse yourself that they don't intersect, then how can they make an angle? Alright. So I write 2 minus alpha equal to 1 plus mu, because x has to be equal to x for intersection. And then I get 1 minus 3 alpha equal to 2 minus 3 mu. So let's do substitution by bringing this 1 to the left, so that this equation becomes 2 minus 1. 1 minus alpha equal to mu. Put that value of mu in the second equation. So 1 minus 3 alpha, this equation becomes 2 minus 3, and in place of mu, I will write 1 minus alpha now. So 1 minus 3 alpha equal to 2 minus 3 plus 3 alpha. Let's put the alphas together. So minus 3 alpha was already here. The second alpha will also be minus equal to 2 minus 3 is minus 1, and this will also go and become minus 1 there. So minus 6 alpha equal to minus 2. So what do we get alpha as? Because we divide by minus 6 here, minus 6 here, alpha comes out to be 1 over 3. What about mu? Mu is 1 minus alpha. So mu is 1 minus alpha, which is 2/3. We got both the values of alpha and mu if they intersect. And how do we confirm that they are actually intersecting? Because getting alpha and mu means they are intersecting in 2 dimensions if they were 2D. But we have to confirm that they are intersecting in 3 dimensions, and that will be confirmed if that z component or z coordinate is also the same. If 1 plus alpha is equal to minus 3 minus 2 mu, then it confirms that they are intersecting, which we don't expect as the question is asking us. So 1 plus alpha equal to minus 3 minus 2 mu, this is what we want. Alpha is 1/3, mu is 2/3. So 1 plus 1/3 equal to minus 3 minus 2, 2/3. So 1 plus 1/3 is 4/3 equal to minus 3, and this will be minus 4/3. So 4/3 definitely is not equal to, this comes out to be 9, 13, minus 13 over 3. See, they are not equal. That means any two simultaneous equation will give you some solution, but in this case we got alpha and mu that did not work with the z coordinate. That means they are not intersecting. So we will say that the z coordinates of the point of intersection does not work out, which means it contradicts the assumption that they intersect, the lines. So hence they don't intersect. Diagram shows the curve y equal to sin x cos 2x from 0 to half pi, and its maximum point m. Okay, half pi means your calculator should be in radians. Find the x coordinates of m. So since they have already said it's a maximum point, that means stationary point, the gradient of the tangent on this line will be 0 because it's a horizontal line. Let's find the differentiation of the function so that we can find the gradient of tangent with that. So y equal to sin x cos 2x, because sin x and cos 2x are multiplying, we'd use product rule for finding the differentiation. So it will be sin x differentiated but no action on cos 2x. In second one, sin x remains sin x, but we will differentiate cos 2x. The differentiation of sin x is cos x, cos 2x. Then we have just sin x. Differentiation of cos 2x will be minus 2 sin 2x, because the differentiation of sin 2x is sin 2x, but we further multiply by the differentiation of the angle, and this is negative because sin 2x is negative for differentiation. Yeah. So what do we get? Cos x cos 2x minus 2 sin x sine 2x. This is equal to 0 for maximum point. Yes, and this is the first maximum point after 0. Let's try to change them, because if one side is 0, other side has to be factored out, but there is nothing common I can see here. Cos x, let me leave cos 2x because it has 3 identities. I want to see which one will match with this one. So minus this minus, then we have 2 sine x, and then we have sine 2x equal to 2 sine x cos x, okay, equal to 0. So it becomes cos x something minus 4 sine square x cos x equal to 0. And yes, we have an identity which will have sine square x. So I will convert this cos 2x into 1 minus 2 sine square x. So we are left with now, because both of them have cos x common, let's take that cos x common. In this we are left with 1 minus 2 sine square x, and this is minus. We have 4 sine square x here because cos x is already taken common. We'll write just 4 sine square x equal to 0. And done. We will get our two equations now very clearly. Let's write here. Cos x 1 minus 6 sine square x equal to 0, and that was the purpose, to get two equations. One will be here, cos x equal to 0, and one from here, 1 minus 6 sine square x equal to 0. Since this is the first angle after 0 straight away, so we have cos x equal to 0. If we draw the graph of cos x, we drew it in previous one of the questions also. So we get here at pi by 2, right? So x will be equal to pi by 2 if it makes sense. Does it? No, it doesn't. Pi by 2 is here. That means that answer is of no use because this is a turning point here. This is what we got from that one. So we will ignore it. So no need to take care of this. Look at this one. 1 equal to 6 sine square x divided by 6. So sine x, if we square root both sides, will be plus minus square root 1 over 6. So x will be sine inverse square root 1 over 6. Since we know that y value, look here, x is a positive value here, y is also positive here, so we will ignore the negative. We'll just write x equal to sine inverse square root 1 over 6. No negative. Why? Because it is on positive side. Alright, so let's put this in a calculator and we'll get the angle. What I got with my calculator is 0.4205, 4 digits after decimal. Did they specify? Yes, 3 significant figures. So that means it will be 0.421 radians, of course. Okay, next part. Using the substitution u equal to cos x, find the area of the shaded region. Okay, there's nothing difficult. We have the starting point of 0. We just have to find the ending point. When is it 0? When is this become 0? So we'll make the main function equal to 0 and we'll find it. But it is the first time after 0 it is becoming 0. So let's see which one is the first thing. Alright. Sin x cos 2x, right? Yeah, sin x cos 2x. Our equation is y equal to sin x cos 2x. And we have to make it equal to y equal to 0 to get x-intercept. So this gives us two situations again. Sin x equal to 0, cos 2x equal to 0. X is sine inverse 0. which is 0, and we can clearly see that one of the x-intercepts in the graph is 0 here. So that answer is again not a surprise. Let's start this one. 2x equal to cos inverse 0. 2x cos inverse 0 in positive. The first time it becomes 0. Again, let's look at the graph. You can see it is pi by 2 here. So we will write pi by 2 as the angle here. So x becomes, if we divide this by 2, divide this by 2, x comes by x equal to pi by 4, which makes perfectly sense. It is in mid of this one, and this we got as pi by 4. But our purpose was to find this shaded area. We just got the limit right now, but we have not found the shaded area. So our limits for finding the area is from 0 to pi by 4, and we will have sin x cos 2x inside. Now they have suggested take u equal to cos x. That means we have to convert this cos 2x into cos x somehow, so that we can take cos x equal to u. Okay, so I'll use the identity cos 2a equal to 2 cos square a minus 1, because it has cos. So I will use that here. So 0 pi by 4 sin x remains sin x. We will have here 2 cos square x minus 1 in place of cos 2x now dx. Alright. So the first part of this becomes, if I multiply sin x with 2, so let's keep 2 outside, sin x cos square x dx minus 1 multiplies with sin x dx. These limits I'll take care on the last step. Okay. So now we know the integration of sin x is cos x, negative cos x, that is. That means this will give us plus cos x and plus c last. Our problem is here where we have to use the substitution they have suggested, u equal to cos x. Yeah, let's do that. So we'll keep it safe. We'll focus on this one. This 2 also we'll take care of. So u equal to cos x, that means du over dx equal to minus sin x. Correct? That means du equal to minus sin x dx. This dx goes and multiplies with sin x. So we have sin x here, dx here, but no negative. Let's create it. This I created, so I have to compensate by creating one more, so that ultimately it becomes positive. So it becomes, let's substitute things. Minus 2 is outside. Minus sin x dx is du, and cos square x will be u square, because we assumed that u is cos x, right? This becomes our very simple integration now. The integration will be minus 2 u cube over 3 plus c, and no need to write plus c because we have already written it here. Since we got it, let's put back cos. So we get minus 2 over 3 cos cube x. This is the integration of the first part. Earlier we got cos x plus c, and now we have to put the limits from 0 to pi by 4. Let's put them now. So minus 2 over 3 cos cube pi by 4 plus cos pi by 4 plus c minus 2 over 3 cos cube 0 plus cos 0 plus c. C and c cancel out. Okay. Cos pi by 4 is 1 over square root 2. So minus 2 over 3. So it will become square root 2 over 2 cube plus square root 2 over 2. This is the value of cos pi by 4 rationalized version. Minus and this minus become positive 2/3, and cos 0 is 1, so it will become 1 cube. Cos 0 is 1, because of this minus it will be minus 1. So let's write 2/3, and then square root cube is 2 square root 2. 2 cube is 8, so cube is gone, plus square root 2/2. Here we can cancel this. 2 times 2 is 4, and 4 times 2 is 8. Here what do we get? 2/3 minus 1. Okay, so minus square root 2/6 plus square root 2/2, and 2/3 minus 1 will be minus 1/3. Let's finish it here. Both of them have square root 2, so write square root 2, and we'll be left with minus 1/6 plus half minus 1/3. So square root 2, and then minus 1/6 will be 2 times 3, 3 minus 1, 2/6, which is 1/3 again, minus 1/3. Take 1/3 common from both. Square root 2 minus 1 is the simplest exact form. I think they are asking exact form only. Simplified exact form. Yes, we got that. This is the simplified exact form of the area.